Hi everyone, this is Rajkumar D, Assistant Professor from Department of Information Technology, Dr. SNS Rajalakshmi College of Arts and Science. I welcome you all for this lecture in multiple access procedures under the subject Introduction to Mobile Computing. So let's move on to the session. So in the previous slides, you must have gone through the mobile computing architectures. So here we are going to discuss about mobile accessing techniques. What are all the different ways we are able to access, or what are all the multiple techniques, or what are the multiple access techniques available in an mobile computing architecture. So as you all know, multiple access procedures are essential for managing how multiple users or devices share a common medium. So common medium is shared by different users, at the same time different devices. So you must have known about this radio frequency spectrum, like All India Radio, or different radio channels we used to hear using this frequency modulation, like 103 FM or Suryan FM, like that. They also use the same band but with different frequencies. So, like this, the mobile computing architecture also depends upon the same communication medium. We will be exploiting with different techniques so that it is using, or it is being used to its maximum effect. So the multiple techniques available are frequency division multiple access FDMA, time division multiple access TDMA, code division multiple access CDMA, and spatial division multiple access SDMA. So first we move on to FDMA, frequency division multiple access. So it allocates different frequency bands to different users. So here each user transmits and receives on an unique frequencies channel. So a same frequency is allocated for a particular user or a particular band. So here the usage is common in all analog systems, and some early digital systems were also using this type of access FDMA. So what are all the advantages? It's very simple in its implementation. It has minimal interference between users if the channels are properly allocated. You must have encountered two signals happening on the same time. Okay, so if there those problems and all comes into actual implementation whenever this is not being properly done. But our main advantage is its minimal interference if the channels are properly allocated. The disadvantage is, since it is using same frequency, the bandwidth is inefficient because usage of different frequency bands are fixed and it cannot be dynamically adjusted, especially when the demands increase. It cannot be dynamically, different frequency cannot be allocated. Only same frequency is fixed, and same frequency alone can be used. That is one of the main disadvantage. To solve this, we were using time division multiple access, where it divides the same frequency it into different time slots and allocated to different users. So here the importance is given to time. So a specific point of time, a specific user is allowed to use a band, use a frequency. At a different point of time, different user is allowed to use the same frequency. So here the usage is common in all cellular systems like GSM. Whenever you talk about a cell phone using SIM card, global system for mobile communication, TDMA is widely used. The advantages is the bandwidths are efficiently used as time slots. That is, dynamically it can be allocated based on demand. A bandwidth can be increased or bandwidth can be decreased based upon its demand. But the disadvantage is we have to use a precise synchronization process where everything has to be managed properly. At the same time, latency can be an issue if it is not properly used. Next one is code division multiple access, where we'll be using different codes, unique codes for different users, which will be using same frequency at the same time. So same frequency, same time, but different code. So here the each signal can be manipulated with code by using different bandwidths. So here it is used in widely used in 3G networks. The advantage is very high capacity and robustness against interference we used to have in frequency division multiple accessing. and it will be having a better security. But the disadvantage is it's very, very complex to implement. At the same time, it requires a very sophisticated signal processing capabilities and power control. Next one is spatial. It uses spatial separation to allow multiple users to share same frequency and time resources. So this technique is widely used in MIMO, multiple input, output operations, where it is employed to achieve this spatial separation. The advantages is the usage of spectrum and spatial resources improves capacity, and it covers a long distance. But again, the disadvantages is using a sophisticated instruments and devices like antennas and a very, very dedicated algorithm, and because of this, it's very difficult to manage. So in this session, we discussed about four different types of different multiple access used in mobile computing. I hope you all understood. We'll meet in the next session. Thank you. These key considerations for multiple access techniques is capacity, coverage, interference management, synchronization, and complexity. We'll meet in the next session.